And welcome everybody to the Daily Space Weather. I'm your host, Dan, aka smAsho. And we've been seeing some spectacular activity out of the northern hemisphere of the closest star. And we've got coronal mass ejections expected to strike late in the day universal time tomorrow. We'll get to all the forecasts in a bit. Here's some more imagery of the closest star. I'm going to zoom out a little bit so you can see date stamps there at the bottom of the screen. This is the last day. And we've actually seen a little bit of a degradation of sunspot 2824, the source of all the flaring that we've seen. We've also got sunspot 2825 having formed behind it to its east, and a possible new sunspot ahead of it up here. Right there. Right there. You can see a new set of umbrae forming there. That could be sunspot 2826. Here's a close-up in non-colorized magnetogram. And the surrounding opposite polarity umbrae around this North Pole-oriented umbra have shrunk a little bit, as has the main sunspot. We're also seeing the Earth-facing quiet effect. And by the way, if you didn't see our videos from the last couple of days, check those out. We've got some spectacular imagery on the last couple of days. And just to give you an idea of what that is, let's take a look at Stereo A. A spacecraft located out here at gravitational equilibrium point Lagrangian point 5, where we're able to see coronal mass ejections facing the Earth. And there were at least 4 of them. You could say 6, depending on how connected you consider them to be. I would note the date stamps at the bottom of the screen. We've got a few days being shown here. And as forecasted, the coronal mass ejections have kind of ceased. We also see the Earth-facing quiet going into effect here, as sunspot 2824 is now in the direct Earth-facing mode, which actually makes it less likely to produce major solar flares. Why is that, folks? Any ideas? Leave a comment if you have an idea why the Earth-facing quiet effect is a thing. There are some logical theories about it, and the most logical one is that the sun is made of condensed matter, liquid metallic hydrogen, which does not emit in a perfectly straight line to a flat surface. So I don't want to get too in-depth into that into the Daily Space Weather video. That's for a cosmology or heliophysics segment. Anyway, here's a close-up of the northern hemisphere. Sunspot 2824, 2825, and the possible newly forming 2826, which is showing up right here. We've also got coronal holes stretching across the equator. We'll get to that too. First, a diagram of the solar system. And there's where things will be in a week. We've got a full moon coming up here on the 26th, and a total lunar eclipse for some part of the planet. Also, here's a star chart from in-the-sky.org showing you what's overhead. Saturn and Jupiter are up there on the ecliptic if you've got a clear view of the morning sky rising ahead of the sun. The 10.7 centimeter radial flux has come up as well. Also forecasted, it's now at 79 solar flux units. Here's a 1-year chart of that. The most proportional data set to sunspot number in terms of solar activity, the 10.7 centimeter radial flux. So here's the NOAA forecast, the Enlil spiral, and they're missing some of the coronal mass ejections on these models. We may see some ejecta arrive earlier. I would say maybe something like midday on the 25th, but that's only a few hours difference, folks. It's very difficult to determine the speed of these things. And we saw multiple different speed coronal mass ejections over the past couple of days there. I counted as many as 6 separate coronal mass ejections. At least 4 of them could be cited, and this model's only really showing 2. And yeah, so take that with a grain of salt. Let's go to global seismicity. There were certainly some interesting quakes, including a 4+ magnitude near Kilauea on Hawaii. So there are the 4+ magnitude quakes. Not a lot of earthquakes happening right now as plasma hurtles toward Earth. There are the 5 magnitude quakes, and that map showing nothing. That's volcanodiscovery.com's sort by magnitude map. And we saw a very shallow quake near Davis, California there. That one 2,000 meters above sea level. Let's just check the location of that one real quick since it's so shallow. And there's the location of that one near Lake Davis. 2,000 meters above sea level there. 2,100 meters. The depth of that 3.1 magnitude quake. So some deep quakes here, such as this 4.2 in South America and this 4.1 in the Mariana Islands region near the deepest part of the ocean. Also, Nicaragua saw a deep quake. Japan saw a deep quake. Another very shallow quake near Lake Davis. So that's perhaps a data set you're interested in. Here's a 2.9 deep quake at Alaska. Also one near Argentina at a 4.9 magnitude, 178 kilometers depth. And here's the rest of the list scrolling for you here. If we missed anything, leave us a comment. So here's this 4.1 quake. The red arrow is pointing to where that 4.1 magnitude quake under Kilauea was located. And let's see what else is on the list here. Looks like a bit of a lull in volcanic activity. So that was located about 9 miles south of the volcano under Helena Pali, area of Hawaii Volcanoes National Park. Sabancaya, producing continuous ash emissions in Peru. In central Chile, Nevados de Chilean exploding, 14,000-foot ash plume there. And Nyiragongo in the Congo has stopped erupting. So the lava lake drained after a fissure opened. It did do some damage, but nothing like the damage done in 2002 to the town. There were at least 15 fatalities, mostly caused by bad driving and panicked people. Also, some prisoners horrifyingly trapped in a building, quote, built by lava. I think they mean built near lava, but in any case, the Nyiragongo volcano has now ceased erupting. A great reminder to not pole vault the caldera. It could be very unhealthful. And here at smAsho we prefer you to be healthful. Here's the Earth-facing quiet effect going into effect. And the Earth-facing quiet effect is an effect of the fact that the surface of the photosphere of the sun is made of a metallic substance, probably liquid metallic hydrogen. It would explain most of cosmology. But in any case, here is the 3-day chart of the GOES X-ray flux. And as we forecasted yesterday, the flaring activity has dropped, at least as detectable from Earth. And the flaring from the perspective of stereo A has probably not dropped. I won't get into it, but anyway, there's the 3-day chart. You can see 3 M-class flares there, so some real activity happening recently. No spikes in the proton flux, not yet. So none of the ejecta from the recent coronal mass ejections have been relativistic ejecta, as sometimes it takes only half an hour for protons to show up after solar flares and coronal mass ejections. Here's a 3-day chart of the GOES magnetometer. And what can I say? It's looking pretty smooth. Earth is in a North Pole-oriented current sheet shown here in green. Nothing to write home about there. This data derived from 51 ground-based magnetometers and magnetometers on stereo A and stereo B. Here's another view of the same data from the line-of-sight perspective. And you can see some changes happening in the B field right there at the beginning of the video near the equator as the solar polar field reversal process commences. Here's a great view of that, the line-of-sight coronal hole plot, and you can see North Pole-oriented coronal holes here stretching over the equator, an indication that the solar polar field reversal process is happening as the North Solar Pole starts to move down toward the equator. So there's some evidence of that. We also see some evidence of the South Pole moving up toward the north. As you can see, a nearly equatorial coronal hole right there. This also shows you the sun's B field in blue. Here are detected filaments and detected sunspot groups You can see this new possible sunspot forming out here. Could be sunspot 2826. And 2824 and 2825 are both just about alpha class sunspots now. The global geomagnetism scenario is at 1, the KP index at 1. Calm geomagnetic conditions, and in fact, a weak solar wind stream, a very weak solar wind stream, getting all the way down to below 1 proton per cubic centimeter there. Very diffuse solar wind right now. Just under 1 proton per cubic centimeter. Solar wind speed 332 kilometers per second, so a very slow and diffuse solar wind speed. Here's a magnetosphere movie of the density, and you can see all that low density area. Just a narrow band of high-density plasma there out at the bow shock and around Earth's poles. Low density here shown in white, high density shown in dark blue. It's 4 hours of data. And you're looking at protons per cubic centimeter plasma density in the geospace out to about 12 Earth diameters or so. Here's the magnetohydrodynamic pressure. Let me bring this back. And you see very weak pressure here, basically like solar minimum conditions. And so when the coronal mass ejection arrives, we're going to see quite a change in the geospace. Hopefully it won't cause any massive natural disasters. We'll be looking for correlations. And if you're not familiar with our mission, check out smashamash.com/forum/mission. Studying things with predictive value is one of our specialties. So here are the ground magnetic perturbations, changes to the Earth's geomagnetic fields, changes to the Earth's B field, you could say. And we don't see very many perturbations during this portion of the polar excursion. If you weren't aware, the South Geomagnetic Pole is someplace down here, south of Australia. The North Net Pole is someplace up here, and we've got one over Siberia as well as one over Canada. 2 North Poles. We've also got some very weak spots in the magnetosphere, the South Atlantic Anomaly and the South African Anomaly, the weakest points. Now, we regularly stream live to Twitch. Today we're not going to do so. This is an exclusive on YouTube. However, follow us on Twitch. We stream live regularly, thanks to our new followers there. And if you don't view the videos on YouTube, you're missing most of the content thanks to our new subscribers on YouTube. Tell your friends, foes, science noobs, and science pros about the channel. There are playlists with all kinds of stuff besides just space weather. Perhaps check out the Shut Up Fauci video. We're also on BitChute, thanks to our subscribers over there. Thanks to our patrons, the main source of funding for the content. Consider becoming a patron at patreon.com if you want the earliest alerts about things like space weather alerts, geomagnetic alerts, and so on, solar activity, also all kinds of multimedia, music, ringtones, and extra perks available. Patreon.com/smashamash. Welcome to the Neo-Renaissance. Visit our own websites as well. A bunch of links can be found on our homepage, smashamash.com. Smashamash.org will redirect you, as we're using smashamash.com to fund smashamash.org. Today, I'm wearing the Do Not Pole Vault the Caldera socks. I won't attempt to show those off. But again, here's the design. And thanks to everybody who's picked up merch of any kind, the Do Not Pole Vault the Caldera merch is quite high quality. And you can get all kinds of things like shirts, tank tops, sweatshirts, different versions of shirts like V-necks, stickers, phone cases, perhaps a tapestry or a tote bag. Cheers. Thanks again, everybody who picked up some merch. Congratulations on not pole vaulting the caldera. Did you know the Neil Gorell Swift Bat X-ray Observatory now has 1,050 objects instead of only 1,031? One of them is a full-spectrum quasar, number 926. And a full-spectrum quasar, what we mean by that, folks, is a quasar that has the full spectrum of electromagnetic radiation coming from it, everywhere from low-frequency radio waves all the way up to X-rays, perhaps coming from this one. It's quasar QSO B2008-159. So there are the X-ray transient outputs from that. Let's look at this full-spectrum quasar in a couple different wavelengths. First of all, here it is in optical on the pan stars. Great high-resolution imagery of that quasar there. Here it is on the 2-mass. It's infrared light. And quasars are a type of active galactic nucleus where the polar field of the galactic nucleus is oriented directly toward you, the observer. Here it is in blue light. And here it is in red light. You can note some differences there in those wavelengths, those portions of the visible light band. That's today's random cosmology object, quasar B 2008-159. And I would bring your attention to the bottom of the page here at the Neil Gorell's Swift Burst Alert Telescope. These items right here are all new items. So we've got a catastrophic variable in there, a Seyfert 2 galaxy, a Seyfert 1.5 galaxy, a supernoval remnant, a BL Lacertae object, a quasar, full spectrum, flare star, dwarf nova, etc. Lots more things now being monitored for their X-ray outputs at the Neil Gorell's. Today's astronomy picture of the day is from Chris Kostiopoulos. A great image of lightning and a total lunar eclipse here from June 15th, 2011. They thought it was going to be too stormy to see it, but they ended up with spectacular imagery instead. apod.nasa.gov if you want to check that out. That's today's cosmology segment. It's integrated into the daily space weather video. Let's continue on to talk about Van Allen belts. Earth's surrounded by them, and during times of geomagnetic storm, we see a third Van Allen belt form, like a larger one out here, and compression of the inner ones, of course. Anyway, there's a diagram of that. The electron content out there can charge up satellites, and currently it's not doing so. And here's the latest graph from the last year of electron flux. We're in a moderate range, and there you can see the 3-day chart of the electron flux as measured at the F layer by the GOES 16. Here's the forecast for electron flux. I would not tend to disagree with that. The green boxes are the forecast, the yellow diamonds are the observation. Here's a visualization of that as your GPS has to communicate with a satellite through a lot of electrons, which can cause massive errors in your GPS. This will give you an idea of where it is. It's a total electron content forecast, and we're seeing some chaotic Van Allen belts here. Some major errors happening at nighttime, especially around this area right here. Africa, the central Atlantic area, and South America will see significant GPS anomalies in the middle of the night. Most of those occur around the equator at noon. Here's another diagram of the atmosphere. Next, we're going to show you the F layer right here, the 300-kilometer F ionosphere at about 300 kilometers of altitude. This is 2 days of data showing you 2 hours per second in vibrational frequency. And that is in megahertz, millions of vibrations per second. Let's bring up the latest image. That is from 9:15 Universal Time. Let's talk about climate. Check out the sea ice thickness. And you can see up here the sea ice volume is right at the bottom of the 20-year range here. The gray shaded region is the 2004 to 2013. That's only a 9-year range. The 9-year range, my mistake. And you can see the black line here, 2021, we're seeing more ice volume than last year and more ice volume than 2017. So last year actually did see pretty low ice volume here. Currently we've got some quite thick areas here at like 4.5 meters of ice. That's all in meters there, folks. And you can see the eastern shore of Greenland completely encased in ice. Let's take a look at surface winds. By the way, you're living through an ice age. If you weren't aware, you are currently living through an ice age. An ice age is defined as a time when the planet sees ice at both poles all year long. And the ice at both poles has not melted during your lifetime or anybody's lifetime. And that's the definition of an ice age. You're currently living in an ice age, folks. And the Earth over the past 33 million years has been much colder most of the time than it is now. Also, the planet's been cooling since the Minoan warm period, about 6,000 years ago. So here are the surface winds of the eastern world. We've got some strong winds there in the Bay of Bengal. It's probably some high seas out there. Here are the jet streams of the eastern world. Let's rotate the planet to the east to show the jet streams of the west. There are those extreme jet stream anomalies here. Meridional jet stream flow, doubled up jet streams over the western portion of the U.S., doubled up jet streams over the U.S.-Canadian border. Funky jet stream flow. Here are the surface winds. And let's blast through some more meteorological data and close this thing out. Lightningmaps.org is where I go when I hear thunder. You could also check out blitzachtung.org, blitzachtung.org. And we've got some lightning in the central U.S. right now in Kansas. Hey, Oakley, there's thunder happening to your west. You may not be able to hear it. Anyway, here's a zoom out once again to your global lightning map. Here's the NASA GOES lightning mapper of visualization. And we did see some pretty extreme lightning there in West Texas. Also in central Minnesota. What are you doing with the final month of spring? Do you have any plans for the solstice? Are you going to be viewing our video when we stream live on June 20th at 11:32 p.m.? The exact moment of the solstice, 9 seconds into that minute. And let's take a look at pressure here. So here's the European model for pressure cells on a global scale. We'll advance this into tomorrow. Here's where the European model expects pressure to be at 12 noon Eastern Daylight Time tomorrow. Here's a U.S. Doppler radar map. As snow continues to fall in Montana, Wyoming, Idaho, Utah, Nevada, and Colorado, and even some in New Mexico and Arizona, it looks like. Although those might be Doppler errors, as those are very small showers. Oftentimes, the Doppler radar picks up things that are not making it to the ground. Anyway, there's the cloud layer. Here's the water vapor map. And you can see a massive area of moisture here stretching from central Mexico all the way up to North Dakota and indeed into Canada. And here's the U.S. Doppler radar map once again. Here's the cloud layer. And there's the water vapor, which should give you the most insight. Here come bonus features. I'm going to press refresh. And the first bonus feature will be hydrogen alpha imagery from the El Teide, Spain ground-based observatory. You can actually see some flaring happening here. You see some flares happening there from Sunspot 2824. And that's pretty new data. Let's see if some X-rays happened while we did the show. Not really, nothing significant. And here's the high-res intensitygram. You can see out here, this could turn into a sunspot. It's degraded since we did show prep, making it less likely to be named. These umbrae back here could actually be named as well, folks. Those are pretty far from Sunspot 2824. That's a separate group, probably. And Sunspot 2825 is looking pretty stable and pretty weak there. Here's a refresh of the colorized magnetogram. And there is some complexity with that new umbral region there. There's Sunspot 2824 and high-res magnetogram. There's Sunspot 2825. Here is a close-up of the northern hemisphere in 335 angstroms. Give it a minute. It's well worth it. That's 24 hours of activity there. Note the time date stamps on the bottom. Again, check out our older videos. There is some spectacular solar imagery in the last couple of videos on our daily space weather playlist. If you haven't checked that out, youtube.com/smashamash/playlists. You'll find all kinds of additional material there. If you are a solar enthusiast. We'll close things out here at 94 angstroms. Thanks for tuning in, folks. Remember to stare at the sun, attempt to understand the physics, don't drink it. If you do, don't drive. And since it'll never be now again, welcome to the Neo-Renaissance. May that solar wind be at your back. And again, significant geomagnetic storm coming here in a day and a half. So be prepared for that. It could cause power outages and all kinds of other communications errors. I've been your host, Dan, a.k.a. smAsho, signing off from the Smash News Network. Least busted. Name and news.